Good morning, everyone. A little starter for you. I would like you to use factorising to solve this quadratic, and then I'd like you to complete the square for the same quadratic, and then I'd like you to use factorising to solve this quadratic, and I'd like you to complete the square for the same quadratic. Have a go, press pause. I'll be back in a minute. Okay, so here's my solution to the first one, factorised quite nicely, giving me two solutions, or two roots, as they're sometimes referred to as. X is 3 and x is minus 1. And then completing the square, so I wrote it out again, shovelled the minus 3 over here. To get this, I need x minus 1 squared, but if I grid that out, I also get a plus 1, so I take away that one. There's the 3 minus 3 that I shovelled out there, so that gives me that. And you remember that that means that if I sketch this, I get a turning point at 1 minus 4, so hopefully you agree with me there. And the second one, well, solving, first thing I do always is line it up. So here I've got my x squareds and my x's and my constant term. Haven't actually done any algebra there, just rewritten it. But then I do my key step. Multiply everything by minus 1. 0 is your friend, stays as 0. And it's important to realise that the solutions we get to this equation are the same as the solutions to this equation. So we don't at the end need to multiply by minus 1 again. This algebraically is the same equation as this. This one solves quite nicely, and therefore my two solutions are 3 and 1. There's a few of you still getting caught out with the completing the square when it's not just a single x squared. It's really worth practicing. But I lined it up and shovelled the minus 3 out there. Then I take out the minus, and I've got x squared minus 4x, which I complete the square for in green. I then multiply it out, which remember doesn't change that bracket at all, but changes the minus 4 to a plus 4. I've then got the minus 3, so that gives me plus 1. And you'll remember that this upends the curve, but doesn't change the turning point. So the turning point is at 2, 1. So how are we going to use that today? Well, what we're going to do is we are going to sketch this quadratic. Now you might be saying, well, hang on a minute, you've given me a fancy calculator that does that for me, and you're right. You could question whether we still need to do this, but it does roll up a number of important techniques that we often need to use in isolation, and I like doing it, so we're going to do it. It's a 4-step process. Those of you I've taught will be familiar with the 4 steps. Why am I numbering them 0, 1, 2, 3? Well, in the textbook, the Active Teach textbook, it only does 1, 2, 3. It skips the first one, so that's why I'm calling the first one step 0. So the first question is, what sort of graph have we got? We know that quadratics are always parabolas. Is it happy or sad? Well, we have a positive x squared, so that means we've got a happy quadratic. Where does the graph cross the y-axis? Well, the only thing I know about that point at the moment is that if I look at its coordinate, the x value is 0. So all I do is ask, what do I get from this if I make x equal to 0? Well, if x is 0, y is equal to 0 squared, 0. Take away 2 lots of 0, still 0, minus 3. So I know that the constant here will always tell me where the y-axis, where it crosses the y-axis, much as it does with the straight line. So I've got, so that little sketch is wrong because it crosses at 0, minus 3. Step 2, where does it cross the x-axis? These are referred to as roots. You can perhaps see why. It's where it sort of enters the ground, and we've already used that term, haven't we? These 2 points here, what they have in common is that y is equal to 0. So to solve that, we make y equal to 0, which means we're left with 0 equals x squared minus 2x minus 3, and we've solved that already up here, look. So we've got our roots already. We've got 3 and minus 1, so I know that this graph crosses the axis at 3, 0 and minus 1, 0. I'm going to write those again here. So minus 1, 0 and 3, 0. And lastly, where's the turning point? Where's the bottom of the curve? It's going to be a minimum because it's a happy one, sometimes referred to as the vertex, and we've already done that by completing the square, haven't we? We know it's 1 minus 4. So rolling all those together, we can, sorry, I can't see that, can you? There we go. Rolling all those together, we can get a sketch. So crosses the y-axis at minus 3. Crosses the x-axis at minus 1, 0 and 3, 0. And turning point at 1, minus 4. And happy. So now, of course, your calculator will do all of that for you, and the G-solve button will tell you the y-axis intersection, the x-axis intersection, and the turning point. So you can always check your answer to these, but that's how to do it manually. Let's look at the other one we did in the starter. So here's the other one that we've just solved and completed the square for. So if we want to sketch it, well, this time we've got a minus x squared, so we know it's going to be a sad one. The x-axis, sorry, the y-axis intersection, that's what you get when x is 0. And when x is 0, you get minus 3. So we know it crosses the y-axis at minus 3. The x-axis intersection are the roots, the values you get when y is 0. And we did that earlier, we solved it and got 3 and 1. And the turning point, which in this case will be a maximum because it's a sad one, we completed the square and got that at 2, 1. You may remember that we also know that the turning point will always be halfway between the two roots. Because of the symmetry of the curve, the turning point will always be halfway between the two roots. So it was in the last one, the two roots were at minus 1 and 3, turning point was at 1. Here we've got roots at 1 and 3, turning point at 2. So let's go ahead and mark up a quick sketch of this one. So crosses the y-axis at minus 3. X-axis intersections are at 1 and 3. And turning point is at 2, 1. And it's sad. There you go. So I'm just going to quickly show you how to do that on the calculator. Okay, so I have entered my function. I'm now going to draw it. I was lucky with my axes. Remember, if the axes don't look right, V window and standard is always a good place to start. You can go and edit your X minimum and max values and your Y minimum max values. Leave the dot alone. The scale is just how often you get the numbers. Exit to get off that page, and then you have to draw again. But you've then got the option of the plus and the cursor to zoom in. And I've zoomed in a bit too far, so I'm going to use the minus there. And then my favourite button of all on the calculator, G-solve. And so it tells me the roots, and that's where it crosses the, well, let's do it in order, shall we? The y-intercept first, so that's that one. 0, minus 3. X, sorry, that was that. G-solve again. The roots, that's where it crosses the axis, 2 of those. So if I press that to get the first one, 1, 0 there, and then I press the right cursor button, it finds the second one, 3, 0. Back to G-solve, and then minimum, well, there isn't a minimum. This is a maximum, so I go to maximum, and it tells me the coordinates 2, 1. So, the calculator does it all for us, but it's important that we don't get de-skilled by the calculator, that we can still do all of the techniques involved.
Right,
here.
I am on page 30 of the active textbook, and exercise 2F has some practice of just this. Question 1 is very straightforward. Sorry, no, it's not very straightforward, but it is just like we've been doing. And I suggest you pick 3 of those and have a go. Some of them are simple single x squared. You've got some negatives, you've got some more than 1 x squared, and then you've got some insanely difficult ones. Pick 3 and have a go. When you come to step 2, finding the roots, use your calculator to solve the equation. Unless you really want to practice factorising, but not all of these will factorise. That's plenty. But some of you might want to have a go at question 2 and question 3, which really do seek to sort of reinforce your understanding of this. So for those of you who are finding this stuff we're doing in Quadratics quite easy, 2 and 3 are really quite interesting questions. If you're thinking, what do these letters mean? P means problem solving, and E means exam type question. Question 3, I can assure you, is a typical exam type question, and it's also a question that you wouldn't be able to use your calculator on. So that's how they're quite clever. Don't forget you've got your solution bank here, which you can use to check your answers. Still waiting for some people to submit their answer to Friday's work, so please send me an email for that. And please tell me if you cannot get onto the active textbook, because that's a real issue. We have a few ways around it, but please don't sit there not being able to get to it and not saying anything. Okay, take care.